Welcome back to my channel. In this video, I would like to talk about Bubble Tea. Bubble Tea is a great package in Go that allows us to do some really cool stuff in the terminal. For example, we can do something like this. You can see it's a piece of text that's keep moving around, and it's also styled very nicely, and it also holds internal state like this. And you can see also that it's going back and forth in the width of the terminal that's allowed. And then if I make this terminal window bigger, it's going to keep going all the way to the end and so on. So this is really cool. Bubble Tea is a fantastic way to build TUIs in Go, and it actually is super powerful. You can build some crazy stuff with it. Today, obviously, we're just going to scratch the surface of it. And to do that, let's start with some theory. So the way Bubble Tea works is it adopts the Elm architecture. The Elm architecture, while the name might not resonate with you, but the idea of the Elm architecture might sound super familiar to you. That's because the Elm architecture inspired a lot of the way we handle state in React and Redux and so on. So the way that works is basically the first building block is a model. Now, the model is basically a store of your state of the TUI. So it's basically the data store that controls the way the TUI is printed to the terminal, right? And it can have, like, if you have toggles, then the toggles will be there, the state of the toggles will be there. If you have text specifically in the TUI, then the content of that text is going to be there, and so on. Once you do have that, the model, which is basically your state, you can take that and print it in with a method called view. Let me not do that because I am obsessive. Let's do that, right? Now you can do that with a method called view. Now, the view method is basically the way you take up that state and print it into the terminal. So basically you have your state here, and then you have the view method, which will basically turn that into a string that gets rendered to the terminal. Fantastic. Once that is rendered into the terminal, all the events that come back from the terminal are going to be passed to another function, another method in this case. This method is called update. And the update method is going to be responsible for taking up those messages that come back from the view or from the terminal, or basically all the event handling that the Bubble Tea package is going to do for us, and then basically update the state with it. So you can imagine this is really like, it's kind of like a closed loop. What happens is we initialize the state here and use that to render something into the terminal with the view method. And then the view method plus some stuff happening with Bubble Tea will handle all the events and send it back to us in terms of messages. As messages, we handle those messages in the update method, and then that update method is going to update the state, and the state is going to reflect back in the view method, and so on and so forth. And that's kind of like how you can get this recursive logic that is always rendering things to your terminal, basically. Cool. So that's kind of like an overview of what we are going to build. Theoretically, let's jump back into the code and let's write this from scratch, basically. So what I'll do here, I have a backup, so let me just make sure that it's there, because this is the third time I record this video. Let's see. So I'm going to basically delete main.go because I'm a badass developer, and then I'll close this. I'm gonna touch main.go from start. Cool. And then I will open up a new Vim, just open up main.go, and we're good to go. Cool. So let's start this absolutely from scratch and just basically apply what we just discussed. So I'm going to have a package here called main. And then the first thing I have to do here is initialize my model. And again, like I said, the model is basically the state that holds, it's basically the struct that holds the state of my TUI. So I'm going to call, there's a type, I'm going to make a type called model, and this type is basically a struct. And then based on the demo that I just showed you earlier, okay, fantastic. Based on the demo that I showed you earlier, all I need to do is just have like a message, which is going to be a string in this case, fantastic. And I also have a count, which is an integer in this case, cool. So these are the two pieces of state that I need to basically render that very basic message that keeps going back and forth. Now, I'm going to build this slowly step by step so you can follow and see how we can actually use the power of Bubble Tea to make something really cool. But in this case, what I'm trying to do right now is basically render that message and then have the counter be modifiable with the keyboard. So again, we're going to do it step by step. Once we have a model, we can actually make a program out of that model in our main function here, and then render that program or basically run it into the terminal. So what I will do here, I'm going to have So yeah, this is not working very well. So I need to import it properly. So I am going to basically copy that from here, because for some reason my imports are not working very well. And this will look like that. And oops, this will look like that. Cool. So t.new program like this. And then I have my model. And then my model here, I'm going to pass, I'm going to make basically, I am making the struct. I don't know what's going on. Something's going on with my autocomplete. But I just say here, the message here is going to be, this is the internal state. This is the internal state like this. I'm going to keep a space like that. Cool. And then I'm going to say count as well. And count is going to start with a value of 0. Cool. So now I got the model and I'm making a new program out of it. What I'll do now is basically run it. So I'm going to say I expect to have an error, and the error will be called T error. And then I'm going to run this program. And then if I do have an error, so if T.error is, or if T error is not nil, I'm just simply going to panic here. And then I'm going to dump T error into the terminal along with that panic. Now, the first thing you will notice here is that there's an error that says, hey, this model that you keep passing into the new program is actually not cool. And the reason why it's not cool is because it doesn't have these methods that we talked about here. So we just have this method, we have the model, but we don't have the view or the update. And there's another method that we will discuss right now as well. So let's actually make those. Now, the model struct that Bubble.T requires, like I said, requires 3 methods. The init, which is something that will tell Bubble.T what to do in the beginning. And then from the Elm architecture, we need a view method and an update method. So let's just do it one by one. Let's give this bad boy an init method. And now this init method is basically going to return a T command. And in this case, we are actually not going to return anything. So, but basically what this method does is basically tell Bubble.T, hey, run this the moment you make the program run. So this is the init method. In this case, I don't want to do anything fancy just yet. So I'm just telling Bubble.T, when you start the program, just don't do anything, man. It's all good. Cool. That will be the first method. Now, with that out of the way, let's make another method, which is basically the view method. The view method is the method that is going to return a string. And remember, this is the method that gets printed into the terminal. Now, I'm going to be super simple here. All I'm going to say here is I'm going to return func.sprint, and then I'm going to render a message, and then m.count. So that's it. That's all I'm going to do. I'm just simply returning that as a sprint. Cool. And then finally, we need one more method, which is basically the update method. Now, the update method is actually really cool. And this is where all the logic for the interactivity comes from. And what this method needs to return, it needs to return a t.model and a t.command. So basically, what this does is we get a message, and then actually I forgot that we always have to get a message here. Yes, we get a message which is type t.message like that, and then based on that message that I talked about earlier, this message will basically come from the events that are happening in the terminal. I'm going to do some stuff, but I have to make sure that I return a model back after I have modified it, and I can also return a command for t to activate for me. Cool. Now, for the sake of simplicity, I am simply going to return the model as it is and basically not return any commands. So right now, I'm not doing anything in the update method. And you can see once I save it now, I don't have any problems now with the model because now I have satisfied the struct that Bubble.T is expecting. So what I do now is basically I have an init method, I have a view method, and I have an update method. Notice my update method is actually quite empty. Let's try to run this for sake of simplicity and then see how it looks like. So if I run this now, I can see this just says this is the internal state, it's just 0, and then there's nothing I can do here. I'm typing everything, command, control C, control D, nothing. I can't exit this. And the reason why this is happening is that Bubble.T just lets you handle things just on your own, right? So right now, when I click Control C, there is a message. There is an event bubbling up, and then Bubble.T will send it as a message, but we are not handling it. So let's do that. So And the only way to exit this is actually to kill this terminal. So I need to open another terminal for me to be able to have anything else. So now what I want to do is actually just handle that message properly. So in here, what I will say is basically I'm going to switch a message, which is basically the type of the message that I'm coming in. So message the type right there. Cool. And then I'm going to switch that message. And then I'm going to say, in the case that message here, in the case that message is a tea.Key message, that's right. In the case if it's a T message, what I will do, I'm going to make another switch statement to message.string. So I'm going to get the string out of that message, and then I'm going to switch on that string again. And if that basically, if the message is basically Control+C, then what I will do is basically return the model as it is. I'm not modifying anything. And then basically return a command for bubble T to do for me, which is in this case, t.quit. Cool. So what I've done here is I've just said, if you get a key message, give me the string of that message. And if it's Control+C, then just quit it. So basically, if I run this again, if I type anything, nothing happens, but Control+C will quit. Fantastic. So in your mind, you can imagine what we're doing right now. We have the message coming across, and then once the message comes across, we are handling it by sending back a t.quit. Cool. Now let's do something more fancy here. So another case that I would like to do is basically change the internal state. So let's do that. So if I get a K, then what I will do is basically m.count++, right? And then I will return the model itself, and then I'm not going to return anything. And then if I get a J, then I am going to say m.count minus, and again, I am going to return the model and no commands to be done. Cool. Let's run that and see how it goes. So if I press K, I'm increasing the internal state. If I press J, I am reducing the internal state. And then you can start in your mind to try to imagine, right, I can see how this is playing out now. I got the messages coming across. I'm handling it into my update function. And then I can update the state, and then bubble T just takes care of everything and runs the view method again. And I get an updated view onto the terminal. Now that is absolutely sick. So right now we do have this method of like moving things around and updating the state. Now, in order for me to move things across, I have to use another really cool library that will come with bubble T. It's called Lipgloss. You can look up Lipgloss, but basically Lipgloss will allow us to basically style things in a very cool way. So what I will do here is I'm going to say I have a var called base style, and this will be equal to Lipgloss, yes, Lipgloss.newStyle, Lipgloss.newStyle, and then I will do a foreground, yes, a foreground color, which is Lipgloss.color, and then I'm going to say this is white. Cool. That's cool. And then I will do another one, which is the background color. In this case, it's called Lipgloss color. And I kid you not, I have this code written in front of me here, which is 7D54F3. Cool. So right now I'm actually styling, like I'm making a style for something I'm going to render into the terminal. And then if I go to my view, instead of doing it that way, what I will do here is basically just do base style.render. And then what I would render instead is basically this string that comes from here. Cool. Let's try that out and then see how it looks like. So this is exactly the style that I just made. It's basically white on a purple background. Fantastic. Lipgloss is amazing. Really. I love it very much. Now, another thing that you can do also with Lipgloss is basically add a margin to the left. So if I put this margin as 2, you can see here that I can kind of like move things around a little bit. Okay, this guy's not needed. Cool, fantastic. So if I do that now, you can see here it's being moved a little bit with that margin to the left. So if I change this number to, say, for example, 10, then you'll see that it's being rendered with a margin of 10. Obviously, margins are a thing. You get that if you've done any web development. Now, what I want to do now is have that margin be changeable. So to do that, it has to be a piece of state. So I'm going to call this xcord, which is going to be an integer, which is really cool. And then what I will do here is basically, I am going to do, I'm going to get basically the margin to be set from x coordinates. And then I need to get mean value for xcord here. And in this case, it's going to be a 0. Cool. Now, what I will do here is I'm going to say if I get L, yes, if I get an L, then what I will do here is I am going to m.xcord ++. Cool. And then I'm going to return the model itself. I'm not going to do anything else. And I'm going to return the model and no commands. So what that will do for me is that I can press K to increase the state, I can press J to reduce the state, and I can press L to move it around. And I'm moving that across this way using the margin left. This is really cool. I love that very much, right? So now you can see here how I'm controlling the state and how everything is being rendered properly. Now, obviously, there are two issues here. One, I can exceed the width of the window. And then two, that it's not being animated. So let's tackle these one by one in sequence. The first thing we are going to tackle is I need a way to basically animate that based on time. To do that, I have to use this special command from T, which is called tick. So what I'll do here, I'll have a function here called do.Tick, right? I'll have a function that's called do.Tick, basically, and this function will return t.command, that's fine. And then what this function will do is it's going to return t.Tick, exactly, t.Tick, and this is ridiculous, but this is the description of the function. And then basically what this will do for me here is basically gonna tell, it's going to tell BubbleT to run this function at the frequency of the time that I'm passing on here. So I'm gonna say this, so basically what this says, every 100 millisecond, run this function that I'm gonna pass on to you. So we are going to pass this function here. Nope, like that. I'm going to pass this function here. So basically what this does is going to get a t, which is a variable. And then what we're going to return here, we need to return a message. So the idea here is that every 100 millisecond, I'm going to return a message. And then I'm going to handle that message in my update to do something. Cool. And again, the whole trick is that t.Tick. T.Tick is basically says, wait 100 milliseconds and then send me that function. Wait 100 milliseconds and then tick that function, tick that function, tick that function. Now, in this case, I have to send my own custom message. And so I'm going to say that there's a new type called tick message in this case. And this type, it can be anything actually. But in this case, it's going to be time.time. Now, this is really important. And you can see here that if I send back tick.message of t, this is working because tick.message as a type actually does satisfy tick.message as an interface. And the reason for that is that tick.message itself is an empty interface. And the idea of having a message being an empty interface is you can send anything. Whatever you want to send, you can send it, and then you can handle it in whatever way you want to handle it. And what we're doing right now is basically sending a time type of message. And then once that comes back, we are going to handle it right now. So because I want this animation to happen on the start, so what I will do here is basically do.Tick. So this is really simple and quite like pristine, basically, is that when you start this program, do this, like do this tick, do this ticking thing. Now, what that will do is basically is going to send that message the moment the program starts after 100 milliseconds. So the program will start 100 milliseconds, and then we're going to send the tick message. Now we need to handle that tick message. Let's do that. So if I get a tick message here, what I will do inside there is really cool. I'm going to say that m.xcord ++, and then I will going to return the model. And then again, I'm going to return the same tick command again. And the idea is you send me the tick message. I'm going to do something. In this case, it's this line here. Right? And then I'm going to do it again. I'm going to send you another tick command. So if I run this again, so you'll see now that this is happening after every 100 milliseconds. It's going to be adding to the margin and then boom, it's going to be added to the margin again. And that's how we get the animation, because it's ticking every 100 milliseconds. Fantastic. So with that being done, what I now need to fix is basically the fact that it goes all the way across the window. Now that's not cool. What I need to do is basically have a way of telling how big the terminal is. So I'm going to say that this is going to be a piece of state called win width is going to be an integer here. And then T is going to send us this basically custom message or like special message that is called window size message, and it's basically a message that will get triggered every time the window size changes. In this case, on init, it changes once. So what I'll do here, I'm going to say that from the message m dot win width, yes, equals message dot width. Cool. And then I'm going to return the model, and I'm going to not return anything. And that basically means that when the program starts, I'm getting a copy of how big the width of the terminal is. So that's really cool. Now, the next thing we need to do is basically change this so that when we are ticking, we need to go left at some point. So the idea is right now I am going all the way to the right, to the right, to the right. At some point, I need to decide that I need to go back to the left, right? So there is a value at which the value of that margin, the x coordinate, at which I need to revert and go back to the left. Cool. Now, to do that, what I will do again is add a piece of state that's called going to the left. So going left here, which is a Boolean. Cool. And then what going left will do, because this is, remember, this is basically the custom message or the custom piece of custom message or custom like state. What I'll do here is basically say this: if m.xcord is bigger than or equal to m.win with minus a specific number, I'm going to find the right number now. Let's just say it's 20. So basically, if I keep increasing m.x coordination all the way so that it's more than the width of the window minus basically the width of the message that I'm going across, then I need to start going the other way around. So if that's the case, what I will do here is I'm going to set going left to true, going left to true, going left to true. Cool. And then what else I'll do if m.xcord is by any means less or equal to 0, then I'm going to say that m going left here equals false, and that will bring it back again to be the other way around. And then finally, I'm going to say if I'm going left, then all I have to do is m.xcord minus minus, right? And then if I'm not going left, then m.x coordination plus plus, oopsie, plus plus, plus plus. Oops, what am I doing? Plus plus. Cool. Let's run this and see how it goes. So it's going to go all the way here. And then at the end, yes, is going to turn back again. And remember, notice how the calculation is not working very well because that 20 is not really accurate. So let's fix that. The way we are going to fix that is that this has to be basically a variable. So that variable will just say, this is going to be message width in this case, which is basically going to come from Lipgloss. So Lipgloss has this function, which is called width of the message that we are sending, and then we need to also have the width of the count that we are sending as well. And in this case, what I'll do is I'm going to say a string convert, because remember, count is an integer, iota of m dot count. Cool. So what I'm doing here, I'm getting the length of the conversion of m dot count into a string. And then finally, I'm going to do here message width. Oops, message width. Message width. Are we Gucci? Yeah, we're Gucci. Let's run that again. And you'll see here, if I increase this to double digits, it goes all the way until I hit the end there. And then I will go back to the other way around once I get there. And that's it. That's the end of this. You can see that I've been rushing a little bit just because of time. The video is already around 24 minutes, but you can see how powerful this is. And obviously I can change the speed. If I go to this 100 here and make this 50, this will happen a lot more frequently, and that will mean that I can do this and it will be a lot more frequently, so it's a lot faster now, and so on. But this is basically how you can do this kind of animation in Bubble Tea. I hope you like this video. If you want to look take a closer look at the code or at other details that I have not covered in this video, you can take a look at the combining blog post on my tea.Dev down below. Let me know what you think in the comments, and I'll see you next time.